Welcome back, friend. Today we'll start the new content in our series, that is Hamming code. You know about the Hamming distance. Now today we'll see the Hamming code for error detection. Actually, Richard uh, Richard Wesley, the name of that scientist who was invented this technique. So that's why its name is Hamming. Okay, his surname. So let's start. Easy to implement Hamming code. Second thing, given by R.W. Hamming, Richard Wesley Hamming. And third one is what? 7-bit Hamming is used commonly. This is the standard thing. Okay. Now here, in that these 7-bit, 4-bit are reserved for the data bit and remaining 3 bits are reserved for parity bit. Okay, here the structure of the 7 bits, so give the nomenclature here. So P1, P2, then P4, D3, D5, D6 and D7. Okay, this is standard thing already given by R.W. Hamming, so you must learn about it or remember these things. So here how to make the fix positions of P1, P2 and P4. So here 2 to the power n, where n is equals to 0, 1, 2 and 3. Suppose here 2 to the power 0. 2 to the power 0 means what? 1. So the first position of our data bit from right to left, this means this one. Okay, this is the value of P1. Here we give. Second, the value of n is what? After that 0 is 1. Now 2 to the power 1, which means what? 2. So the second position for parity bit is fixed. The next value of n is what? 2. So 2 to the power 4. 1, 0, 1. Now, yes, 2. 2 to the power 2, it means what? 4. At the fourth position here, we are giving P4. Okay, P1, P2 and P4. Clear? So these are the 3 positions for parity bits and rest of the places for the data bits. Okay. If you are unable to understand, then please go backward and again listen these things. Okay. So the position of P will be fixed by using this formula. Give the power of 2's from 0 to respective number. Here the next, suppose here 2 to the power 3, it means what? 4. It means 8. We don't have a 8 number bit, so that's why we don't need to take here. If in your example, if in your study, if the number of bits are come position 8 number, then you should be use, then you can use further numbers. Okay, the further value of n's. Okay, now next here, this parity bit associated with data bit, this thing is standard thing, you must remember this. Okay, so here P1 is associated with D3, D5 and D7. So the value of D3, D5 and D7 is what? The value of D3 is what? Here suppose 0. The value of D5 is what? 1. The value of D3 is what? Repeat again. Okay, so the value of D3 is what? 0. The value of D5 is what? 1. And the value of D7 is what? 0. Okay, so here we know the number of ones are in order. So after that, adding the value of P, if we are dealing with even parity, then the value of P is 1, then and then only it becomes number of ones are even. If we are dealing with odd parity, then the value of P is what? 0. We'll see in next example in detail how it works. So these associativity of parity P1, P2 and P4, you must be learn this one. Okay, suppose here we are having we are having data bit 1011. So draw the 7-bit block like I draw here and give the numbers. This is D7, D6, D5 and this is D3. Clear? The position of D3, D5, D6 and D7. Okay, and this is the position of P1, P2 and P3. Okay, so if we are dealing with even parity, then suppose now we know the associativity of P1 is what? D3, D5 and D7. Now check the value of D3. D3 is what? Here 1. D5 is what? 1. And D7 is what? 1. So here this is what? D3, D5 and D7. We are dealing with even parity. Okay, we are dealing with even parity. Now here the bits are what? Odd. So make it even. Then the value of P1 should be what? 1. Then it becomes even parity. Are you getting me? Clear? Okay. So now here the value of P is what? 1. So P1, the value of P1 is what? 1. We give here the value of P1 is 1. Now next, the associativity of P2. The associativity of P2 is what? D3, D6 and D7. Check the value of D3, D6 and D7. So D6 is what? 0. D3 is what? D3 is 1. Then D6 is what? 0. And last D7 is what? 1. We are dealing with even parity. Now here we got the even number of ones here. Then so the value of P2 is what? The value of P2 is 0. Why? Because of we are dealing with even parity. And so here the number of ones are even already in data word. So parity bit should be 0. Then and then only it becomes even parity. So that's why the value of P2 is what? The value of P2 is 0. Now next P3. It's P4. I'm extremely sorry. Okay, so see the associativity of P4 is what? D5, D6 and D7. Now check here. First of all, D5 is what? 1. Then D6 is what? 0. Then D7 is what? Yes, D7 is 1. Now here we are dealing with even parity. Clear? So the value of P4 is what? 0. Then and then only it becomes even. So here again the value of P4 is what? 0. This is P2. This is P4 and this is P1. P1, P2 and P4. Now we have the complete code word, that is what? 1, 0, 1, 0. This is what? 0, 0 and 1. 1, 0, 1, 0, then 1, then 0 and then last 1. This is our code word. Code word means what? Data word plus parity bit. Okay, this is what our code word, and we are having here code word. Okay, so look at here, how is going to detect the error. Okay, suppose instead of our data word is what? 1, 0, 1, 0, 1, 0, 1. Instead of this, if we're getting here 1, 1, 1, 0, 1, 0, 1. So how to check it? So first of all, we know the associativity of D3 is what? P1 is what? D3, D5 and D7. So check the values of D3, D5 and D7. So we know already the value of D3, D5 and D7. So here D3 is what? 1. In our example, D5 is what? D5 is 1 and D7 is what? D7 is again 1. Now here, and the value of P1 is also 1. Fine. no problem. Why? Because of we're dealing with even parity. So P1 is correct. P1 is correct, no problem. Now next, P2. Check the associativity of P2. The associativity of P2 is what? D3, D6 and D7. Now check it. The values of P2 is what? So the value of P2 is here, D3 is 1, then D6 is 0 and D7 is what? D7 is 1. Now here, suppose we know the value of P1 is 1 as per the receiving end. The received data is this instead of our code word. Suppose here P1 is 1, then no problem in a P1. In P2, here the value of D7 is 1, no problem. D6 is 0, D3 is 1. So now here the number of ones are even. The number of ones are even, but the value of P2 is what? 0. So here P2, where is our P2? This is P1 and this is P2. Okay. So the value of P2 is the value of P2 is the value of P2 is 0. So after that, counting the number of ones, so number of ones are even, so P2 is not 1. If the number of ones are even, it means what? Here somewhere is error. Here somewhere is error. Check for the P4. Now P4, the associativity of P4 is what? D5, then D6 and D7. Check the bits of it. D7, yes, D5 is 1, D6 is 0 and D7 is 1. Okay. Now here the number of ones are even, but here see the value of this is P1, this is P2 and this is P4. The value of P4 is 0. So here we are having the number of ones in even, so then the value of P4 is not 0. It means what? Again, in the combination of D5, D6, D7, somewhere is error. Okay, we get why? Because of we are dealing with even parity. We are dealing with what? Even parity. So that's why the value of P1, P2 and P4 should be 1. Why? Because of we are dealing with even parity. If we are dealing with odd parity, then it's allowed. Okay. So here again we got somewhere is error. So in our next lecture, we'll see how to correct this error. Okay. So if you have any problem regarding this lecture, then please comment me in comment box your question, your query. I will try to solve it or resolve it as per my level. Okay. Thanks for watching my video. Please like, share and subscribe my YouTube channel Dharaz Infotech for getting upcoming videos.